right, so this first one, limit as x goes to 0 of all of that. You want to start by trying to plug in 0. So when you plug in 0 here, cosine of 0 is 1. Here's your unit circle. Here's 0 pi. Cosine is the x part of the coordinates, so that's 1. So your numerator is 1 minus 1, which gives you 0. And if you plug in 0 to the denominator, that's also going to be 0. So you get that form 0 over 0, which means we're going to do L'Hopital's rule. So I'm going to have limit as x goes to 0, and then we're going to do the derivatives of the numerator and the denominator separately. It's not a quotient rule. We're going to do the derivatives separately. So if we're looking at the numerator, 1 is a constant, so that's going to be gone. I'm just going to cover that up. We have negative cosine squared of 2x. That is a chain rule with 3 links in the chain. The first function is the squared, and then inside of that we have cosine, and then inside of that we have 2x. So first the 2 is going to come down. It's going to drop to a 1. You can put the 1 if you want to. If not, you don't have to. All right, that takes care of the squared. Now we're going to do derivative of cosine, which is negative sine. And then we're going to chain on the derivative of 2x, which is 2. So there were 3 links in the chain. All right, denominator, we're going to have an easier time. That parentheses 2x squared is 4x squared. I would just go ahead and square what's under there. I think that makes it easier to do a derivative. Derivative of 4x squared gives us 8x. And then I'm going to clean this up a little bit, cancel out these negatives and see what we end up with here. This will be limit as x goes to 0. Negatives are going to cancel. I'm going to put the 2 out front. Oh, actually, there's already a 2 there. So 2 times 2 would be 4. This is 4 cosine of 2x sine of 2x over 8x. So we did the numerator, derivative of the numerator, derivative of the denominator. It's L'Hopital's rule. Now, unfortunately, when you go to plug in 0, cosine of 0 is 1, but sine of 0 is 0. So that makes the whole numerator go to 0. And yeah, the denominator is also 0. So we have to do it again. This is kind of evil for a multiple choice question because you have to do L'Hopital's rule twice. And when you go to do the derivative of this numerator, it's now a product rule because you have 2 functions being multiplied. So this is our first function. This is our second function. Not a bad problem. It's just a lot of work and you have to know your derivative rules. All right, so here we did chain rule for that one. There's going to be another chain rule here for the 2x, but this is a product rule. First function is that 4 cosine of 2x. So first function times derivative of the second. Derivative of sine is cosine. So we're going to have cosine of 2x. And you have to multiply on a 2 for the chain rule. So I'm just going to kind of put that out front. So first times derivative of the second plus the second function, sine of 2x, times derivative of the first. So derivative of cosine is negative sine. So we're going to have negative 4 sine of 2x, and then you have to multiply on another 2 for the chain rule. So 4 times 2 will give us 8. So that's our product rule for the numerator. First derivative of the second plus second derivative of the first. And there were chain rules in there for the 2x's as well. I promise the hard work is done now, though, because derivative of 8x is just 8. And so this is going to work this time when we go to plug in 0, because we're not going to get a 0 in the denominator anymore. All right, so let's see what we get. Cosine of 0 is 1 times 4 is 4. Again, cosine of 0 is 1 times 2 is 2. Plus, now sine of 0 is 0. So this entire thing, all of that is going to just be nothing. And then over 8. So we get 8 over 8, which is 1. So 1 is your answer to that. So that one is D. Some of these are pretty hard. That was a lot of work for a multiple choice question. You had to really know your chain rule and your product rule. All right, number 2, this is another tough one. They give us this piecewise function. Let f be the function defined above. At what values of x, if any, is f not differentiable? So the 2 values that we're going to have to test are where the domain splits. So we're going to have to test -1 and +2. So you can actually dismiss choice C right off the bat. because the only values we have to test are -1 and +2, and this one has a -2 in it, which isn't even going to be an issue. So you can get rid of C right off the bat. All right, so let's test each of these. Let me test x equals -1 first. So in order to be differentiable, and that's what this is asking, where is the function differentiable? The function has to be continuous and differentiable, which means the two pieces of the function have to meet up. That's continuity. So they have to meet and link up, and the derivatives from each side have to be equal as well. So first, let's see if this links up at -1. We're going to plug -1 in here, and that'll give us -2. And then we're going to plug -1 into this piece of the function. That'll be -1 squared minus 3. That would be 1 minus 3, which is -2. So those come out the same. So the function is continuous there. I know that the two pieces meet up. Now we're going to do the same thing for the derivative. So let's find the derivative of this first piece. Now that is 2x to the -1. So when you do that derivative, the -1 comes down, it'll become a -2, and you subtract 1 from the power. So it'll become x to the -2, which will put that in the denominator. So that derivative is -2 over x squared. And if you plug in -1, that's the value we want to test here. -1 squared would be 1, and so this gives us -2 for that result. Now we're going to do the same thing for the other piece of the function. Take the derivative and plug in -1. We're trying to see if they match up. So this derivative is 2x, and if you plug in -1, you get -2. So the two pieces of the function meet up. That means it's continuous, and the two derivatives, the derivative from the left and the derivative from the right, are also the same. So this the function is differentiable at x equals -1. So -1 is good. All right, now let's try 2. Now we're looking at these two pieces of the function. First, I want to make sure that it's continuous, make sure that they link up at 2. So we're going to plug in 2 to each piece of this. So if we plug in 2 here, that's going to give us 4 minus 3, which is 1. And if we plug in 2 here, that gives us 8 minus 3, which is 5. So this function is not continuous. So I don't even need to check if it's differentiable. If it's not continuous, it's not going to be differentiable either. And so how did they word this? It says, at what values, if any, is f not differentiable? Well, we found it was differentiable at -1, but it's not differentiable at 2. So B is our answer for that. And again, I wanted you to put an answer for everything. If you didn't really understand that question, but you still put B, give yourself a point. You know, you still get it, even if you guessed it right, because no one's going to know. All right, number 3, we're given a table for f, f prime, g, and g prime. And they tell us h of x equals f times g plus 2g of x. Find h prime of 1. All right, I would consider this a little bit of an easier question than either of the first two. I feel like number 1 and number 2 were pretty hard. This one's not so bad. Now you do still need to know your derivative rules. F times g is a product rule. So it's first derivative of the second plus second derivative of the first. That's just knowing your product rule. All right, plus, and then it would be 2g prime of x. So derivative of g is just g prime. There just happens to be a 2 there. All right, and then they want us to plug in 1, and we're just going to get all these values from the table. So there's no like arithmetic here. You just are going to get all the values from the table. So f of 1 is 2. G prime of 1 is 3. G of 1 is -5. F prime of 1 is -4. And then 2 times g prime of 1, which is 3. So let's see, this is 6. Negatives cancel, so plus 20 plus 6, that would be 32. So A for that one. All right, next one. If, and then they give you this statement where the x's and y's are all jumbled up together. So if all that's true, then find dy dx. This is implicit differentiation. All your x's and y's are all mixed up. Every time you do a derivative of y, you have to chain on a dy dx. All right, so derivative of x cubed, that will be 3x squared. Now this is a product rule. 2x is the first function, y is the second function. So it's another product rule. However, when we do the product rule, we're going to subtract. It's like you're distributing the negative into the product rule. You're subtracting both parts of it. So instead of adding, we're going to subtract because this whole term is being subtracted here. So again, a product rule. This is like the third product rule we've seen here. Your derivative rules are really important. All right, it's first, which is 2x. Derivative of the second. Derivative of y is dy dx. Now again, normally it would be plus, but we're subtracting here. The second function, which is y, times derivative of the first. Derivative of 2x is just 2. So we had a product rule for that part. Plus, now this would be 6y dy dx. Again, every time you do a derivative of y, you have to chain on dy dx. And then the most common mistake here is people will write equals 7. And I get why that happens. But remember, you're doing a derivative, and the derivative of a constant is 0. All right, so now our job is to do all the algebra of getting dy dx by itself. These two terms are going to move over to the other side. So I'm going to add over this 2y and subtract over the 3x squared. So I moved over this term, I added over the 2y, and I subtracted over the 3x squared. So both of those migrated to the other side. Now out of what's left, I'm going to factor out a dy dx. And I probably did not leave enough space for that. Let me move that over a little bit. So when you factor out a dy dx, you're going to be left with negative 2x plus 6y. And then that's going to get divided to the other side. Now, I don't know how they wrote this. Obviously I have the answer choices covered up. They might have this like in a different order. Let me see what they have written here. Yeah, it looks like they put the 3x squared first. And it also looks like they may have taken out a negative. Let me see what they did here. They rearranged this. So you'd have negative 3x squared plus 2y over negative 2x plus 6y. Yeah, it looks like they multiplied everything by a negative. So you'd have a positive 3x squared minus 2y and then a positive 2x minus 6y. They factored out a negative, so B for that one. That's the other thing you have to fight through here is not only doing the problem, but then figuring out which answer choice matches with yours, because sometimes they rearrange it a different way or simplify it a different way. And so like not only the calculus, but you have to get through, figuring out how they wrote the answer. All right, number 5, the radius of a right circular cylinder is increasing at a rate of 2 units per second. This is a related rate. So the, what did they say, is the radius is increasing. So dr dt is 2 units per second. I'm not going to worry about the units. They just called them units, and none of the answer choices have units. So I'm not going to worry about that too much. Just dr dt is 2. The height is decreasing, right? So that's going to be a negative rate, 5 units per second. So dh dt is negative 5. Which of the following expressions gives the rate at which the volume of the cylinder is changing? So dv dt is what we're looking for. And they give you an expression for volume. So we need to take that derivative. And again, it's going to be a product rule. They really liked product rule here. Your first function is the pi r squared, and your second function is the h. Right, so product rule. First, pi r squared times derivative of the second, that's dh dt. Everything's with respect to time. Plus the second function times derivative of the first. So derivative of pi r squared, you're going to bring the 2 down. It'll drop to a 1. You can put the 1 there if you want. And then chain on dr dt. Again, everything is with respect to time. And then we're going to plug in these 2 values that they gave us. So here, dh dt is negative 5. So this is going to be negative 5 pi r squared. And then dr dt is 2. Now I've got another 2 in there. So 2 times 2 would be 4 h pi r. I don't know what order they're going to write this in. H times pi times r times pi times h. I don't know, whatever order they multiplied that in. Let's see what they put for the choices. Oh, and they wrote it the other way around. So they have the 4 pi rh. Of course, they wrote it in the other order. minus 5 pi r squared. So C for that one. All right, so here is one of these. If you want to look back at where I taught this, this is in Unit 6. I believe it was the first lesson in Unit 6. If not the first one, then the second one. You're just matching these up. I'm going to show you which one's the right answer, and you can kind of look through and see the others, why it's the wrong answer. The answer for this one is C. And let me write it out so that I can kind of label some things on here. So whatever's underneath this square root, that's representing the variable. So that's why this says square root of x. Whatever's under there, that's the variable. So square root of x. Whatever's here, that's where you started. So if you think of this as integral from a to b, a is 2. So we're starting at 2. And then this 4 that you see here, that represents the change. So your interval is 4 units long. So if you started with 2 and you went 4 units, you landed at 6. So 2 to 6. Again, you're just picking which one of these matches up with that. So again, whatever's underneath there, that represents x. Like whatever's the guts of it, that's the variable. So it's square root of x. Here's where you started. And then this is the change. That's delta x is 4. So the length of the interval is 4. So C is the answer for that one. And again, if you guessed it, you got it right. All right, number 7. The figure above gives the graph of the continuous function g on the interval 0 to 8. Let h of x be this accumulation function. Accumulation starts at 3. On what intervals is h increasing? All right, increasing means that your derivative should be what? I'm going to throw this question at you. This is the first one I'm throwing at you guys. If your function is increasing, what should be going on with your derivative? Your derivative should be what? Good, nice job, guys, perfect. Nice, good job, you know your sticky note, right? If your function is increasing, your derivative should be positive. So let's find the derivative. Derivative of an integral is going to cancel out. You just get what's inside, which is this graph of g. I hope you guys are getting used to that. That's typically, like, I hope we've done enough problems that you're seeing. They typically give you the derivative graph. Like there have been a couple times they give the second derivative graph, which is kind of weird, but usually they give the derivative graph. So we just want where this derivative is positive. That means above sea level. So that's going to be this section 0 to 1. And then also this section, so 3 to 7. So 0 to 1 and 3 to 7. So C for that one. I like that question. That was an easier one. All right, 8, we are just going to do the antiderivative. This is going to be a U substitution. Right? How do you know when you need U substitution? If the problem is more complicated than just being able to write the answer, like just do it backwards, then you need a U substitution. We're going to let U equal the inside stuff, like the guts of the problem. So 1 minus 9x squared. That derivative, 1 is a constant, so that's gone. That will be negative 18x dx. And we're going to need to adjust that with a negative 1/18. All right, so if you want to highlight, the part that we're going to substitute out for is the x and the dx. We're going to put negative 1/18 out front, du at the end. This is taken care of. So what's still there is square root of u, but it's in the denominator. It would look like this. Hey, everybody, I want to rewrite that as u to a power. What do I want the power on u to be? If I rewrite this so it's u to the something, what is the exponent going to be? Oh, good, you guys are awesome. I'm seeing some response there. Nice. It will be negative since u is in the denominator, and a half since it's a square root. So it's kind of a double whammy. It's a 1/2 since it's in a square root, and it's negative since it's in the denominator. All right, now antiderivative. You're going to add 1 to the power. Negative 1/2 plus 1 will be positive 1/2. And then that reciprocal goes out front. So negative 1/18 times 2, that would be 2/18, which would be a 9th. u to the 1/2 means square root, and u is this. It always sounds like I don't know my grammar when I'm saying this. U is, anyway, you put the 1 minus 9x squared back in. It was a square root because of the 1/2. Just multiplying these together gives you -1/9, and that is your answer. So that one is, what is that, A. All right, number 9. We're matching up which one of these goes with that slope field. So what you want to notice is all of the rows are the same. That means there should only be a y in the differential equation. Remember, if all the columns are the same, it's only x. If all the rows are the same, it's only y. So you can narrow it down to A or B just based on that. So we've narrowed it down to these two. And then you kind of want to focus on either the 0 slopes or the undefined slopes. This is the easiest ones to look for. We have 0 slopes at 2 and at -2. And this is the choice where if you plug in 2 or -2, you're going to end up with 0 because you would have 4 minus 4 in the numerator. So number 9 is B. And again, that's just a matter of matching that up. Hold on, I gotta bend the paper over again. Let R be the region bounded by the graph of x equals e to the y. Now, before I even go any further, you want to graph x equals e to the y. Hey guys, how do we cancel out e? Which function cancels out e? Because that's what I'm going to want to do to both sides here to make this look a little bit nicer. Good, I heard from a couple of you there. ln. If you ln both sides of this, you get ln of x equals y. Oh, whoops, ripping the paper here. The ln and the e cancel out. So I would think of it that way. Now we're still going to want the equation written in this format, but if you ln both sides, you get ln of x equals y. Here's your graph of ln of x, that sideways swoop. You should just know what that one looks like. Like you should just have that in your back pocket. That's your natural log graph. Asymptote here, sideways swoop. All right, so that's that graph. Vertical line x equals 10, so that's going to be right here. And then the horizontal lines 1 and 2. All right, so here's a horizontal line at 1, here's a horizontal line at 2. So this is the area that we're talking about. We had 4 graphs that were enclosing that. So it was your ln of x graph, your x equals 10, and then these 2 horizontal lines. So which of the following gives the area for R? It's going to be a dy problem. It's a right graph minus left graph kind of thing. And this was your big clue, is that this was written x equals. So our integral will be from 1 to 2. There are y values there, from 1 to 2. And we want to do right graph minus left graph. So it's 10 minus e to the y. So again, integral from 1 to 2, and then right graph minus left graph, 10 minus e to the y. So that one is C. All right, and then these are going to be the calculator allowed ones, which doesn't mean that we'll need a calculator for every single one. It just means that you're allowed it. So we probably will need it at some point. And yeah, looking at number 12, there's a lot of decimals there, so we are going to need it in a second. All right, number 11, the graph of the function f is shown. We want limit as x goes to 1 from the right. So as we are approaching 1 just from the right side, there's a hole, but I don't care. It's just where's the graph headed? Remember, a limit is just behavior. From the right side, the graph is approaching 2. So 2 for that one. So 11 is C. All right, number 12, we are given the velocity of a particle. And this is really weird. The function went down to the next line. Let me write it out so that it's all on one line. Velocity is 1.3 t ln of 0.2 t plus 0.4. I feel like that was almost kind of rude. They didn't fix that. Like the equation went down to the next line. Anyway, what is the acceleration of the particle at time 1.2? All right, hey guys, how do you get from velocity to acceleration? What do we do to get from V to A, from velocity to acceleration? Derivative, good, nice job. And then where is derivative on our calculator? Because we get a calculator, we're going to just type it in. This is kind of a no work problem. Where is derivative on our calculator? Good, nice job, math 8. All right, we're going to go to math 8, d dx. I'm going to put in this function and then such that 1.2. This is 1.3x. What is it? ln of 0.2x plus 0.2. And then such that x equals 0.2, and it will literally just tell us the answer. So negative 0.093. They always round up for the multiple choice. Negative 0.093, so that one is C. I like that question. I was just typing in the calculator. I like 11 too. You just had to look at the graph and pick your answer. Kind of nice. All right, 13. Let f be a twice differentiable function. We're given values in the table for f prime. Which of the following statements must be true? So letter A, the graph is increasing. Well, at first glance, it looks like all the derivative values are positive, but we don't know what's happening in between these, and it could drop down to a negative number. So we can't have that. Can't be it. B, the graph is concave down. Well, you would need your first derivative to be decreasing all the time for that. Concave down means your derivative would be decreasing. And again, at first glance, it looks like 11, 9, 8, 5, 2. But again, I don't know what's happening in between. In between these, it could go back up. So we can't like guarantee that. All right, and then these last two say there exists a C from -1 to 5 such that, now this one says derivative equals -3/2, and this one says second derivative equals -3/2. This is your mean values theorem. It's saying your slope equals your derivative. And if you take these 2 points, what is it? -1, 11 and 5, 2. If you slope them, you're going to have 2 minus 11 over 5 minus -1. That'd be +1. So -9, 6, which would be -3/2. That's where they're getting that -3/2 if you do the slope. We just need to pick if it's the derivative or the second derivative. And here's where I kind of don't like this question. I think this is really tricky because for mean value theorem, typically it is the first derivative equals the slope. Derivative equals slope. So if you pick C, I don't blame you for that at all. The answer is D though, and it's kind of like a trick question. They made this f prime already. So when it's derivative equals slope, it's derivative of a derivative. That's why it's the second derivative. If this had just said f of x, then it would have been answer choice C. But because it's f prime, mean value theorem is the derivative equals the slope. And when you do the derivative of the derivative, it's second derivative. So anyway, D for that one. I feel like that kind of was a little tricky though. All right, number 14. Let f be the function defined with a derivative of this. This is our first derivative. How many points of inflection? All right, what we're going to do is look at it. So I'm going to type it in on the calculator. A point of inflection is a change in concavity. So that's where your first derivative changes increasing to decreasing or decreasing to increasing. So we're going to type this first derivative into y equals, and we're going to see how many times it changes from going up to going down or vice versa. All right, so this is 2 plus parentheses 2x minus 8 close parentheses sine x plus 3. Did they give us a window? Yeah, the window is 0 to 9. So we're going to go to window, make that 0 to 9. I must have been something else here. Change your y's back to standard, -10 to 10. That's just always a good place to start. You can always adjust it from there, but it's just -10 to 10 is a good place to start. So it looks like we're going to have not a critical point, an inflection point. We're going to have an inflection point here and here and here and here. So there are 4 of them. It doesn't ask what they are, just how many are there. And there are 4 of them, so that is D. All right, and then number 15, honey is poured through a funnel at a rate of, all right, and then they give you that R of T function, times in minutes. How many ounces of honey are poured through the funnel from time 0 to time 3? All right, we want to accumulate honey from 0 to 3. All right, so this is math 9, 0 to 3, and then we're going to put that R of T function in here, which is 4e to the power negative 0.35x dx. So we get 7.429. And so that one is D.